All right, welcome everyone. We're here for a new presentation in this series of seminars. We have today Álvaro Soto. It's a pleasure to have Álvaro with us. Álvaro is the director of the Center for Artificial Intelligence in Chile, Cenia. This is a very big Latin American center. So Álvaro is an engineer at the Pontificia Universidad, Católica, Chile. Took his Master of Science from Louisiana State University and took a Doctor of Philosophy at Carnegie Mellon University. We were there a long time ago together. He works with machine learning, cognitive robotics, visual recognition, big data. He's a professor at the Department of Computer Science at UC, a co-founder of a startup. Startup is Zippedi, a Chilean robot company. And he's, of course, the director of the Chilean Center on Artificial Intelligence. He will talk about that to us during the next hour. So, Álvaro, please take the floor is yours. Thank you.
Okay, well, thank you very much, Fabio, for the introduction. It's a pleasure for me to be giving you this talk and to see you again now, long time from our times at CMU. Well, I was talking with Fabio a couple of days ago about what should I address in this talk, and so he told me that most of the people in the audience are more in the technical side, so I will start sharing some of the research that my own research actually that I have been doing in Chile at Católica University, and then I will tell you more about this Center for AI in Chile, give you an introduction of the main goals, and in particular I will tell you about a project that we have to train a large language model about knowledge of Latin America. So that's is the agenda. So I will start providing you some of the motivations that are behind our current research. Actually, the research that we have been doing during the last times in our group. Our group or my group, or the one that I work on, is mostly PhD students and master students. We are a group of around 10 to 15 people. And one of our motivation is I can give you an insight about that. In the story tells that in one occasion in an interview, somebody asked Albert Einstein about if he can explain relativity, but in simple terms. So with ingenious Einstein respond that, okay, he can do that. But before that, he asked to these people to explain him how to cook an egg, how to fry an egg. But he said to this person that when he goes with the explanation, he shouldn't really assume that he knows anything about an egg or fire or a saucepan or all these things that you need to fry an egg. No? And this story for us tell us some of the main problems that we are facing today when we are training the AI models. No, we are providing a very high level semantic information, but we are kind of missing sometimes important information to build really more informative models. No, so one of the motivation that we have in our research is how we can provide a more informative information to this model, so they can really grasp some more truthful theories about how our world works. And so that was the motivation. And the other motivation is, I can see from this example. No? There are some child that was born with a problem in one of the eye. And if you don't do anything about this problem in one of the eye, they have problems to control the eye. So if you can do anything about this child will go all the life with the problem in the eye. No, he will really be controlling just one of the eye. But usually the solution to the problem is very easy. You just cover the good eye and force the child to use the eye that he has problem with the control, and the problem is solved. So that also tells us about the power of intervention. No? If you in a learning process perform the right intervention, you can maybe help, in this case of AI, a model to build more truthful or more useful representation about the whatever data the model is intended to model. So in our research, we are using a lot these two ideas, and we call this coaching our AI models, and try to provide some labels of semantic information so the model can build more useful internal representation of the world. I mean, they avoid this problem of spurious correlation, or maybe not using the right causal models about the phenomenon that the model is intended to do. So I will now show you some example of how we have been able to apply these ideas in real cases. So this was a research that we presented in ICCB, I think 1 or 2 years ago. So the main motivation of this research was in the context of visual language navigation. So the problem is a robot or a model receive images. He have a visual sensor, and also receive some instruction in natural language, something like this, like head upstairs, walk right, yada, yada, yada. And there's there is a benchmark related to this type of data, and the observation behind our approach to this was that all this training data is provided manually. You ask humans to provide this instruction, and usually you use for this some real environments. And when the humans build this instruction, they are intended really to give this instruction to another humans. Now, if you read this, it's the way that a human will really provide navigational instruction to another humans. But instead of navigation, we humans are really expert. It's like Einstein, we is expert in physics. In this case, we are expert in navigation. So this is really a very, very difficult instruction for a model that start with random weights. And as a result, usually the result that you see when you train models using this data is that they perform kind of good performance in the case of the environment that they were used for the training data. But when you measure the performance in new environments, in unseen environments, the performance really go down. And so they don't really generalize very well. So what we did here is try to provide more information, more coaching of this in the data for the model. And what we did is, actually this data has information about the bounding boxes for the objects that the robot, in the images that the robot see in the different path for the correct navigation. And using that information, we did something like this. The green instruction are the original instruction that you can see in the original data. And what we did is that we did data augmentation, and we enrich the instruction, providing more information about this object, the object that the model will see in the environment. So we enrich the information to make it more easier for the model do the right path. Well, as a result, in this work, what we observe is that the first observation was that when you test the model, just the original model, not the one that we were proposing, it was very interesting that when you, so these are two models, the self-monitoring and regressive agent, and when you try this blind, in the sense that you just provide the instruction, but you don't provide the visual information, this is one of the results, the performance metric, the SR is a successful rate. It measures for the different rounds, how many of them you get to the final target position. So in this case, when you don't provide the visual information, actually the model still has some reasonable performance, no, it's like 30%. So this means that even the model, in some cases, even they don't use the visual information. No? It's really a memory, and actually for the unseen environment, it's kind of the same. But you see that in terms of the performance, when you get the visual information, it's almost half. It's more than 20% reduction in the performance. So in the case that we now increase the information, and also we provide some auxiliary tasks to the model. I mean, we provide to the model some tasks related to the identification of the objects that we had labels in the images. For the case of the scene environment, performance of this is our model. Is a little bit increased with respect to the benchmark with the, this is a state-of-the-art model, just 1%. So it's mostly the same. But we see more increase in the performance when we test in a unseen environment. So what this means is that in our case, we increase the level of performance, specifically in unseen environment. No? So this is, in some sense, it's a demonstration of this idea that if we simplify the information to make the life more easy to the model, it is able to increase the generalization. So, okay. I don't see you. I don't hear anything. Are you still there? Some feedback, please. Yeah. Okay, guys. Good. Okay, this is heartbeat. No? Once in a while, I will ask you for heartbeat, because if I lost connection, I won't really realize if you are still there. Okay, so that's one of our research. And then we in a collaboration with people from Stanford University, we follow this idea of increasing the semantic information that a robot, in this case, used for navigation in natural environments. So the usual technology that today is very common for the navigation of this robot is based on depth information and range information. You use depth sensor to create navigational map like this one, where you identify obstacles and areas where the robot can navigate. But if you see humans, we don't really use that symmetric map, that navigation map. We use mostly topological map, where we had some label of specific places like offices and corridors, and you had some behaviors that you use to move from one of these places, between these places. Maybe to go from an office one to a corridor, maybe you need to apply the behavior, go out of office, and then follow the corridor, and then you get to another office. So we try to use a more semantic representation like this one. And to do that, we train different behaviors for a robot. We train behaviors like turn left, turn right, corridor follow, find a door, straight, and other behaviors. And the idea was using those behaviors to navigate in an office environment. This is the type of office environment. Actually, this is the computer science department from Stanford University. So the idea now was the robot go from point A to point B using this a topological representation of this environment and this set of behavior that we train. So this is the complete model. We have the map, and we use a graph neural network to find the node where the localization, or what is the node in the map where the robot is located. And also we use traditional path planning to find the path in terms of the topological map to move from the starting point to the goal position. And then using this two information, we train a model to select the behavior, from the list of, or the library of previously learned behaviors to select the one that it should apply. And the result was kind of very good. The model was able, this is the image that the robot was seeing. This used also a depth images. And this is, in this case, the path that the robot was doing. So this works reasonably well. And one of the problems that this model has was the identification of the transition between behaviors. For example, if the robot, the next step was to execute a behavior going to an office, when the robot was following this corridor, it has different options to go into an office. So sometimes they has the problem that it goes into the wrong office. So to solve that problem, this is a paper that we published actually a couple of months ago this year. It was a collaboration with people from Yale University, and we used the concept of affordance. What means about affordance is that we identify in the environment the different opportunities that the robot has to execute its behaviors. And then we relate the topological map to the difference affordance and that is in this paper. So I will check my time. Well, so I will need to hurry up. So, well, that's some of our work in the area of robot navigation. We had also some work in action recognition. It's kind of a similar idea. In this case, this is for recognition of a set of action, and we help the model in this case adding some auxiliary tasks. Instead of only doing the recognition of the action class, we also add several auxiliary tasks, such as the bounding box recognition, the actor identification, the segmentation of the actor, and that helps for the model. So this is an example of the. So this is one of the sequence, one of the videos where we identify the action. We identify bounding boxes for the main actors. And then we also do the masks for the segmentations. And what we notice is that if you use these auxiliary tasks, all they help to increase the performance in the different tasks. So we had also some work in the case of multimodal application. This is an application that we did for the identification of, we call this approach the fact embedding. We presented this work in ACL this year. The novelty about this is that we had this is a very usual application where we have this on X-ray images. And we also had the report, the medical report about the images. So we use one of the public language model to select all the facts that we were present in the medical report. And then we use a model to create an embedding of this fact and also use some grounding in which part of the image the different fact were present. And that's something that we did there. So I will stop there. My goal was mostly show you some examples of the type of activities that we do in our lab related to this model. Mostly are related to visual navigation, and textual understanding. So that's mostly our areas. And one of the things that I would like to point out also is about the collaboration in LATAM. And I haven't seen that in North America, for example, there are a lot of collaboration between different universities. And sometimes these universities are very far. In this case, it's a university in the East Coast collaboration with a university in the West Coast. And I think in Latin America, there's not really much collaboration. So one thing I have been having in the last month different meetings with people that are working in the AI strategy from Brazil, and I think it's very good. And I really would love to foster collaboration between Chile and Brazil in AI. Okay, so one of the things that I have been also working a lot during the last years is some companies. I co-found 2 companies related to robotics, and one of them started around 7 years ago. And this company is a robot that is for grocery store, and maybe I can show you a video. So this is a robot. And the goal is to navigate through the store. It's a big retail store, and monitoring the products that are in the shelf, and detecting some operational problem, such as wrong price labels, or maybe a stock out situation, or checking if the space that a product is using in the shelf is the correct size and the correct space. And so this is now the current version of the robot. This is a robot that we installed last March. This is a store of Kinds. This is in Japan. And now the robot is checking this area. They call this the end caps. These areas of the grocery store are very important because they had a lot of revenue from the product in the end caps. So at this point, we have around 200 of these robots, and so in different places. So the technologies behind these robots are mainly 3 technologies. One of them is the autonomous navigation. So the robot, this is the place where the robot lives. So every day the robot starts operation, wanders, navigate across the whole store, and then the second technology is related to detecting operational problem in the shelf. One of them is the price label. So the robot detects the prices in the shelf and see if the price is the same that in the master database of the store. So that's one of the use. The other one is detecting the space. I mean, if the product is using the right space. And the other one is detecting like shelf out problems, places of the shelf where there are no product, like in this case. So that is all the perception of the robot. All this mostly run in the cloud. So the robot take the images when it's doing the navigation, do some filtering, and send the images to the cloud to do the processing. And the third technology is the integration of these measurements over the operational problems with the associate from the store, not that they are in charge of fixing the problems that are detected by the robot. Today, the company, we are not really still in Brazil, but we have robots in different parts of the world. And tonight, more than 200 robots will wander in different stores or different chains in the world. I don't know if anyone has any questions so far.
I think it's best to leave to the end.
Okay.
Okay. We are recording, so at the end we do the questions.
Okay. No problem. Okay. So, well, maybe this is the last video. This is a new version of the robot. So this is not still in operation in the store, but the new thing is now the robot is able to manipulate the product in the shelf. So the idea here is that the robot receives an online order, and then the robot goes through the aisle in the store, picking the products in the order. So this robot has a friend or a company, and so this robot is in charge of moving all this structure with the order to the place where the people then package the different orders. So this is still in at the level of the lab, but we hope soon we can be able to also offer this robot in our portfolio of products. Okay, so that's mostly about my own activities in research and now also in these companies. And as the second part of the talk, I will tell you a little bit about the Cenia. Cenia is the Chilean National Center for AI. So the original Cenia is mostly in the Chilean national policy for strategy for AI, and that was published in 2021. So I was part of the committee that developed this policy, and one of the things that the committee points out is that the need for having a research center dedicated to foster an ecosystem of AI in the country. So there are foreign universities, in the case Católica University, Universidad of Chile, Universidad Adolfo Ibáñez, and Universidad Técnica Federico Santa Maria join forces to fund this, start this center, and also receive some funding from the government. And this is a national center, so then other universities start being involved with the activities of the center. And at this point, the center has around 180 members, mostly all the group of researchers that are, some researchers are full-time researchers from Cenia, and other ones are had a double appointment with the different universities. We had also a group of engineers that are doing all the tech transfer, all the operational team, and also a group of PhD students. That's mostly the team behind Cenia. We are very active in research, so we publish more than 100 papers every year, and we are very oriented to conferences of rank A and journals Q1. So we try to promote very high-end research. We also have alliances with different companies and government agencies to do the tech transfer. And mostly we have three main dimensions of activity: research, tech transfer, and outreach. So in terms of research, we have five research lines. The first one is related to machine learning, or mostly deep learning and generative AI models, with application mostly in visual recognition and language. Then we have another line that is more classical AI, mostly the deductive AI and the neurosymbolic AI. We have also a research line related to people from neuroscience and cognitive psychology. So the idea here is to learn from how the brains solve the cognitive problems to enrich our ideas in AI. There's another line related to causal models, mostly people from math and physics. Is trying to use the theories of these areas to create more causal models. And finally, we had a line related to human-centered AI, that try to see problems such as bias or privacy in general to see what problems should we work on in order to foster the positive benefit of AI. So in terms of text transfer, we had a group of around 24 at this point engineers that are doing the text transfer. So the idea here is that in my own experience, most of the things that we do at the university level, at least in Chile, they end up at the level of a lab implementation. So the idea here, in order to have in Cenia a very professional group of developers, mostly people in software engineering, was to foster a group that is able to pack the solution of AI in product that are at the level of what the people expect in the industry. So that's the idea. And we had at this point association with several Chilean companies, all levels, big companies, medium-sized startups, and we do different applications. They actually, Cenia has already 3 years, so it's 3 years old, and we have a lot of project that we already did, or per project we are currently under development. And most of these initiatives are related to language application, I mean NLP, visual recognition, optimization using AI. That's mostly the areas where we have some previous projects. In terms of outreach, we have different activities with local school and communities. And one of the things that has been really very successful for us is the Latin AI Index. What is this? This is a study of 3 main dimensions. How the different countries in Latin America are doing in terms of the infrastructure needed to develop AI, how they are doing in terms of the adoption and the development of AI, and how they are doing in terms of regulation and governance. So actually, a couple of weeks ago, on September 24th, we presented the second version, version 2024 of the ILIA. And in this study, we also had the first version in 2023, including in this case 19 countries. Actually, Brazil is doing pretty well. And so these are the 19 countries, and there are 3 countries in Latin America that, according to the different metrics in this dimension, are the one in better position to develop AI, and this is our Uruguay, Brazil, and Chile. And there are some countries that are in the middle ground, and there are other countries that. So how we obtain this? This is kind of the average score. It actually is a weighted average that weight according to the relevance of the different metrics for the development of AI. And the average of all this axis is this score. So to give you an example, this is a graph of the enabling factors. So in this case, there are 3 enabling factors. In the blue bar is the physical infrastructure, like the connectivity, for example, computing infrastructure. In orange is the data, how easy it is to get data sources in these countries. And the green one is the human resources. As you see here, in terms of Brazil, for example, they are doing had a very good score in terms of infrastructure, and maybe still need more to do in terms of human resources. So it's important to notice that all these scores are normalized by the population. So Brazil probably is the one with, because of the population. Now Mexico and Brazil, in terms of absolute numbers, are doing pretty well. But when you normalize, this is the score that you have. So we also, in this study, provide a chart like this one, where you can compare the average of the different countries in LATAM with respect to Brazil. So in general, Brazil is doing pretty well. And probably with the new strategy, it will be the number one in Latam. So I had, okay, 10 minutes. So in the last part of my talk, I would like to tell you about a special initiative that we are running currently in Cenia. What is the idea of training a LATAM large language model? So we see this as similar to sending a rocket to Mars. It's a very difficult project. And so difficult that we need really the collaboration of all the countries, to send this rocket to Mars. So I will briefly tell you why this is important. What is what we need to build in order to do this, and a possible how. So let's start with the why. So currently, one of the problems, if you really start working a little bit with the public LLMs, is that they know little about Latin America and the Caribbean. For example, now if I did this a couple of weeks ago, I asked to the Meta tool, what is a Chilean? And this is a Chilean. So, well, it's kind of nice, but I don't really feel very close to this Chilean. So this example shows that, I mean, this model doesn't know that much about Latin America. And actually, if you see the sources of data that are mostly used to train this model, you see that most of the information are coming from English. I mean, in English, probably it can be information about Latin American English, but probably most of the information there is coming from other parts of the world. So most of the problem is that this model use information mostly from data, not from other parts of the world. Also, if you see this model, they don't really include. They know about Portuguese, Spain, Spain, but they don't know Spanish, sorry, but they don't know much about other languages, and there's a bunch of languages in Latin America from mostly the original people. So another motivation for this is to achieve some technological sovereignty in AI. You can see that different countries and different regions are really pushing to develop or to be in position to develop this technology. That's the case of, in this case, the United Arab Emirates that developed Falcon, or Saudi Arabia that developed Alam, or China, or India, or in this case, Mistral, that is an iconic model from French. Actually, last January, the Economist has an article describing how the different countries are trying to push the technology so they can be not just users of this technology, but also they are in position to develop this type of technology. So, and this is from the Stanford AI Index from last year. And if you see what this graph shows is how different parts of the world are developing these foundational models. And sadly, you don't see anyone in our part of the world. There's a lot of models in the north part of the world, but actually not in Africa or in Latin America. So to me, at least, these are two relevant motivation to make the effort to develop this technology in Latin America and the Caribbean. So then the question is, okay, what is needed actually to develop this model? And when you see the inner working of this model, there are three main skills or capacities that they need to achieve in order to work in a proper way. So the first one is just the language, the syntax and the grammar. I mean, from Portuguese, from Spanish, or other language. And the experience tells that that's not really that difficult for this problem, but for these models. No, if you had a model of for current standard not so big, I mean a model around for example 3 billion parameters, you can really have some good capabilities in terms of a language. So, but this capability makes the model to build right sentences, with the right position for the article, for the verb, for the noun, and so on. But now, when you have a dialogue with this model, when you use this model, all this language should build some good sentences, sentences that are related to the topic that you are talking with the model, you are interacting with the model. So that's the knowledge. And so you need this model to store some relevant. So I had to go. I had to put my, okay. And the third capability is reasoning. You will like this model to have some reasoning capabilities. So, well, probably you know about the GPT-3. So it's a big model. It's the first one that shows that when you have some large data and look a lot of computing, these three capabilities emerge. So the thing is that if you once you really have a model with a lot of knowledge, you require a lot of resources. And our estimation is that if we want to build a model that knows a lot about Latin America, we need a model with over 50 billion parameters. So that means we need a lot of computing. And also you need a lot of data. And our estimation that at least you need more than 300 billion tokens. So these are thousands of millions. And so the how is one possible how is what we are trying to put in Cenia. So we build the ILIA in a collaborative way. So there's different groups in all Latin America helping to build this index. And we think that we can do the same with this Latin and Caribbean LLM. And we have been working more than 1 year, almost 2 years in this initiative. Also, there are people and groups at this point from 9 countries, and there are more than 100 people working on this. And we organize this in 5 groups. Some group is working in the model, the implementation of the model. Other group is working in the data. Other one is working in the alignment. You know that after the pre-training, you need to align the model in order to have good interaction with the user. Another group is working in the evaluation. So how you evaluate that the language model that we developed has some good capabilities for good knowledge about Latin America. And the other one is working in low resource languages. So I mean, besides Spanish and Portuguese, more languages for Latin America. So I will skip this because I think I am on my time. Sorry. So we had some question. And so the invitation here is to be part of this. I mean, this is a very difficult project. Maybe I will back to one point is that we had at this point some computing, because one of the main obstacle to do this is the computer power. So at this point, we had in Cenia 24 petaflops. This is for operation in floating point 16. But now we are currently building an infrastructure that will have around 200 GPUs, H200, and that will increase our computer power to 400 petaflops. And we had an estimation that with that computing power, we can train models of around 7 billion. So we have the computer power. We can collectively have the data. And the idea is to have all this model open. And so all the community in Latin America can use. So the idea in this project is mostly to develop the skill and the capacities. So different people, I mean, from academic institutions, from companies, can use these technologies. So that's mostly what I had to tell you today. Thank you very much for your attention.
So I think, well, thanks a lot, Álvaro. I think we have time for questions. I think.
Yeah. Sorry, it was a lot of stuff, and
yes.
but feel free to ask me anything.
Yeah, maybe we have some questions, but I have questions, so I will.
Go ahead.
Actually, I have several questions, but let me ask a question per part of your talk. So you're doing robotics with LLMs inside. Aren't you afraid that the robots will hallucinate and start running over people and stuff like that? So that's one question. So yes. The second question is about your Cenia. So you have research lines. We have also research challenges here. We call research challenges. How do you decide which challenges you will invest? How many years do you plan to invest in each one of these lines, or are you changing or not? And last thing, maybe if you have time, the LLM, the Latin American LLM, do you plan to have it trained from scratch? Or, I think you told me about this already, but I guess maybe you can elaborate.
Okay, I can do that.
Start from a transformer, zero transformer, and then learn everything? Or do you plan to start with some other model? So maybe you can answer.
Yes. Okay. So a lot of questions. Let's go for the first one. It's kind of the easy one. So in this robot, we don't use foundational models. No, we have some specific models for doing the recognition of product or the recognition of label. So what is it? What is so? When one of the things that I have been learning, when I'm now working in this industrial area, just with a company, is that cost is key. I mean, if you go to the customer and the cost is not really a good value for them, no robot. So while we are trying to, we put a lot of attention in our design to make a solution that is scale, that the robot is cheap, and also because we need to pay the cloud. We run all this on cloud, and we need to pay for these GPUs that the robot use every day. So we try to use the less. Actually, some of our models are not running in GPUs because we don't really need real-time operation. Because the robot can get the images and they don't really need the result right now. They can wait for a couple hours. So we are running some of these models in CPU. Why? Because it's cheaper. GPUs in cloud are really expensive. I learned now that if you can avoid GPUs in cloud, well, that's a good decision for cost. So that's mostly the answer for that. Cost is important. And the second question about the areas that we are covering at this point at Cenia. So Cenia has a development plan for 5 years. Actually, we received a lot of money from the government, and that is because they approve this development plan for these 5 years. So now in November, we will start our 4th year. And when we finish these 5 years, we need to make a new plan. The funding for this project from the government is for 10 years with an evaluation and a new development plan at the end of the 5 years. And actually, the funding from this center are coming from the government, half of the money, and from private companies, all the activities that we do in tech transfer. That should be only the other half. So, at the end of the 5 years, we had to decide if we continue with the same research line or if we make some adjustment to them. And the third question about if we are training this LLM from scratch, actually, to me, if you really had lot of data, it doesn't really make that difference. I mean, you can see, for example, the case of Falcon. No, actually not Falcon, is Alam. That is the model from Saudi Arabia. I was visiting Saudi Arabia 1 or 2 months ago, and I talked to them, and what they did is that they really start not from scratch. Actually, they tried both, starting from scratch and starting from the weight of llama, one of the weight from llama. And they had some issue because the tokenization was different, because they had a different alphabet, different symbols. So they had to. It was not so easy, because they started from the weight of llama, but they had to introduce a new tokenization to adjust for the new symbols from the Arabic alphabet. And I mean, they told me that they really, when you train with small data, it's better to start. I mean, small data is, I don't know, 200-300 billion tokens. Maybe you have a small increase in performance if you start from the weight that you previously trained. But if you really had a lot of data, the results are really similar, because I mean, you have this problem of catastrophic forgetting, that when the new data start like to override the value of the weight from the previous training. So, I mean, probably one can saying that they did in Saudi Arabia, you can test both, and at least at this point, I think that both, if you had a lot of data, both should lead to similar results. But well, we will need to test that. But I think that the key thing is you have to really have the computer resources to train a model that is more than 50 billion. If you really want a model that knows a lot about Latin America, when I mean knows a lot about Latin America, is that knows about the culture, the politics, the literature, the geography, and that is the goal.
Thank you. Yeah, questions? Maybe you can come here.
Okay, so we have two questions. One of them was because you mentioned that Cenia, one of the research lines was about causal models. So I wanted to know if you could tell me more about the problems you're tackling regarding causal models, and also regarding the Latin American LLM. You're saying you're using uh, data from Latin American countries to increase the knowledge of the model, and I wanted to know where those data come from.
Okay, great. So the first question about the causal model. So the idea there is that people in different scientific areas, like, I don't know, physics or biology, they build theories about the field. I mean, like in physics, you build really causal models. So the idea creating that research line was to bring together people that are mostly working in causal models. So people that are working in physics, or that's what they do, and put it together with people that are training this AI models, in order to work together to see, I mean, what are really the aspect or the approaches that we need to include in this model. But for us, one of the main problems today with the current AI models is that they are not very causal. No, they really suffer from problems such as spurious correlation and other problems. They are not systematic. For example, they have a lot of problems with systematic reasoning. And so the idea is, well, let's put this guy together and see what they discover. That was mostly what is behind. And also we bring there people from math. We believe that in order to so, for example, they are studying what are the transformer learning, and that's what they do there. It's very exploratory research line. And the second question about the data. So the idea there is for example, I mean, I went once to give a talk to the people, to librarians, in Chile. So I told them about this initiative, about the Latin GPT, and I discovered that they had a lot of data. And so then I talked with the people in Mexico, guys from Mexico, go to talk with the librarians, go there, the guys in Colombia, and that has to be more, it's very bottom up, in the sense that I told you there's more than 100 people, and these 100 people are really knocking doors, to see different sources of data, and there are groups, for example, in Mexico, there's a group that has, I don't know, they had around more than 10 years of data from Twitter. So they share that data with us. There are people that has some relation with a very old newspaper from Peru that has 100 of history of news from there are people that are working with the Congress. So the Congress has all the meetings in text. And the idea is just, let's bring this. Actually, we are now trying to write a paper about this. Because this is a new way to collect data. All these big models, the way that they do is they scrap the web. And well, all the problems that you can find if you do that. But this is what they do, the companies, because they have some limitation to really do this collective approach to collect data. Then we are seeing, well, what about if we really join forces, from groups of people in the different countries, and we are all working together to create this big repository of data. And I hope most of the data doesn't have restriction. So then when we open the model, we can also open at least a big a chunk of this data for different applications.
Okay,
so this is why we need help from people from Brazil too, because we need more Portuguese and data from Brazil.
Okay, well, thank you. So we have, I think this is streamed, so we have people watching. So we have questions from the online viewers. Maybe we can just select a couple of them. So my colleague, Professor Naldo Cândido, asks, how much data do you think is required to train a consistent LLM? So this is one question. Maybe we have time for 2 or maybe 3 at most, but maybe we can address this one.
Well, yes, I mean, based on, there's some papers, there's a paper by Hoffman, and also there are some experience of all other models, and we think that if we can collect more than 300 billion tokens, that is around 225 billion words. Now, from Latin America, we will be in good shape. Actually, we can't really go that much further, because if the data set is bigger, we put more pressure in our computing resources. So, I mean, we are targeting at this point probably to finish with a data set of around 1 tera byte the data, and mostly more than 300 billion tokens from Latin America. That's our target now.
Okay, so we have another question by this next one, Leonardo. So he asks about the first part. So do your robots generalize with new products and with products placed in different shelves?
Actually, no. We had because, I mean, as I told you, we tried to go from cheaper solution. So we had a list of products, and we do the detection of those products. What we do is that in the recognition, we are also reading the text in the products. So with the text reading, we can at least detect if there is some new product. But usually what we do with that is we report that to the store. Now, this is a product that you don't have in your database. But we don't do much about that. We try to really do the supervision of the list of products that the store tell us that these are my products. But I mean, but the limitation there is mostly because we are trying to use the cheapest solution that we can afford in order to you had a more convenient price for the stores.
Okay, so just one last question. So we finished. Oh, there's one online question. There are more online questions. So I'll take one online question. That's all. And then I'll have one final question here from the audience. This is a question from Eric. Many times people create and train a single model for the languages for Portuguese and Spanish. So I guess the question is, are you planning to do it?
Yes. Yeah, just to give you an example, most of these big models, they also include code, like Python code. I mean, and if you think Python is another language, I mean, it has its own syntax and grammar, and usually what you observe is that if you include the code, usually the reasoning abilities of the model are increased. So to me, the models doesn't have too much problem to learn languages. I mean, Spanish, Portuguese, and a single model can do that. Actually, can really afford to learn these two languages. I don't see a main problem with that. I mean,
okay. So one last question here from the in-person audience. So I'll let me introduce you, Claudio. Claudio is a researcher from IBM. IBM is actually our partner here in our center, and Claudio is the deputy director. So Claudio has a final question here for you.
Nice to meet you.
Great work. You mentioned that you're also looking into indigenous languages. We are doing a project here regarding creating technology, doing things like translators and similar for indigenous languages in Brazil. And there is one issue that we are starting to face, which I think an LLM for Latin America will also face in a different level, which is when you see how people actually talk in these communities, there is a lot of code switching. There's a lot of both language and culture switching. They use Portuguese and their language. They use cultural elements from their culture and from the other language. And there is a problem that probably are going to face in Ireland, for example. The system you have to learn culture from Latin America and from US, because people talk about the two things. What we found is very hard. Data that often data is one culture, one language. It's especially weighted. So how we are going to tackle, how we are going to find code switching data that probably we will need for doing a good job with these guys.
Okay.
A data element for Latin America.
Yes, I mean, let me link this question with the previous one. I said that languages is not a problem for this technology, but when I talk about, maybe I had to make a double click there, is that when you are talking about languages of where you have access to a lot of data, I think that's not really a problem. But when you face with languages that has low resources, for example, in our case, we develop a translation for the two main languages from the native Indian in Chile is Mapudungun and the languages that they call in, I don't know if it's a place in Chile that's called Easter Island. So they had also their own languages. And in that case, we had these problems. For example, we had ready a first version of these tools, and we went to the Eastern Island to make this. I mean, the text, with the people, so the people can use it. And I recall two cases. One of them is that they test the system with the prompt of astronaut. And it was a very good test, because I mean this word astronaut or the word computer doesn't exist in the original language. They don't have a special word for astronaut. So in that case, for example, the translation of the tool in the case of astronaut was a worker of the stars. So that is kind of the problem that you need to face, is in the sense that how you can do a translation that makes sense in the original languages for new concepts that are not really, they don't have a special word. And to do that, in our case, what we did is that we work a lot with the community. That was not really getting a data and doing the training. We had several iterations with the communities in order to calibrate, in order to develop the ending tool. So I think that in a short answer for your question is that when you face the problem of adding these low resources languages to this model, you need to really do something special. It's not a question of just doing the data and then adjusting the parameters. I don't know if that makes sense to you.
Yeah, so let me just...
So I mean, actually, I can, if you are working on this, so we have already these tools for the Chilean native languages, and actually now we're in contact with people in Paraguay for the Guarani, and we're working with people in Mexico for the Nahuatl, is a language from the Aztecas. There, so I mean, I'm very happy to get you in contact with the guy that is in charge of that initiative.
Yeah, so actually, I think let me advertise a little bit. So Claudio is leading a group doing work with Brazilian indigenous languages. I think it's maybe something that at some point you guys will interact. And,
yeah, great. Yes, yes.
Of course. With that, let me finish. Let me thank you again, Álvaro. This is great. Thanks a lot, and congratulations for all the work with your center.
Thank you.
Come here. If you were here, you would enjoy some coffee and.
Okay, great. Yes, yes. So I'm coming to Brazil to the event in December. So maybe I can escape to Sao Paulo during that trip.
Yes, we'll have you here then. Okay. Bye-bye.
Okay. Well, thank you very much. Bye-bye.